11.1 Inference about two population proportions. All right. So a sampling method is independent when an individual selected for one sample does not dictate the individual to be in a second sample. Whereas dependent is the opposite of that. If our first individual determines the second individual in the second sample. Okay. Now, dependent samples are often referred to as matched pairs, and it is possible for an individual to be matched against him or herself. All right, so the first thing we need to determine if things are independent or dependent, then determine whether it's qualitative or quantitative on those pieces. Okay, so here we have this class. There are 1,200 students enrolled in a traditional lecture and 300 in a lab-based. Once they're done with the course, they are given a grade. And the study was to determine whether the proportion of students who passed the lab-based exceeded that of the lecture format. And so we see these are independent because one of them does not affect the other with those. Students aren't in both classes. It's not the same student picked from each course and things like that. They're independent, okay, for those. All right, so the next one is we have this product from Amazon. We want to know if it's less expensive than the same product from Walmart. And so they identify these products and they go and determine the selling price at Amazon and Walmart and see if there's a significant difference. This is dependent. Even though we're buying from Amazon and then Walmart, it's the same product. So what I purchase at Amazon must be purchased at Walmart, and so it dictates what is going on there from those pieces, okay? All right, so test hypothesis regarding population proportions here. So suppose that we have a random sample, N1, and it's taken from a population X1. And then we have a random sample N2 that's independent from a population of X2. So we're going to be doing a lot of different things here on those. So here are all the different formulas. We're going to have p hat 1, p hat 2. We're going to have our mu of those different things. And then we also have our sigma from all of those. Okay, so you got all these formulas here, but we are going to look in the calculator and see how to deal with all of these different formulas. Okay, we also have our z value. We are talking about proportion here for these, and so we are going to look at our z tables as possible use there, z values. All right, so our pooled estimate of p is just p hat there, and so that's a combination of things. So we want to pay attention to all of these different things, right? And then as well our test statistic for those. Okay. All right, now a lot of things still remain the same here, looking at our percentages and greater than 10 that we've done before on those pieces. We also have our hypothesis testing. Again, still the same for two-tailed, left-tailed, right-tailed on those pieces. So it's just all about, you know, what do we have so we know what direction in order to compare all of these things. Okay, so we have our classical approach. We can look at our z sub 0 and then compare that to our z sub alpha on those pieces. And then we can also look at our p-value and see if our p-value is less than the alpha as well. Okay. All right, so here's our first example, and so we want to look at all of our pieces. It says that we have this trial of Nasonex there, 74 adult and adolescent patients. They were divided into two groups. Group 1 received the Nasonex, while Group 2 received a placebo. Of the 2,103 patients in the first group, 547 reported headaches as a side effect. Of the 1671 in the control group, 368 reported headaches. Is there evidence to conclude the proportion of Nasonex users who experience headaches is greater than the control group? Okay. Now, again, they're going to do everything on here by hand. We're going to show you how to do it in the calculator, but I am going to use some of their information that they've just already got it sorted a little bit easier for us. Okay. Okay, so we know first and foremost that they are independent because they're randomly assigned a treatment. But then we have our groups. So X1 and N1, that's our first group, and then X2 and N2 is our second group there for that. Okay, so we are going to use that information here for our hypothesis test. All right, now to get into our hypothesis test, we are just going to go into, let's turn the calculator on. Let's go to Stat and over to Tests. Okay, so we clicked Stat, over to Tests. Excuse me. And then down to, because we're dealing with two things, we're going to deal with 2-prop Z test, because that's what we're doing there for those. Okay. All right. Now the samples are independent because of the treatment, but here we can see we have X1, so we're going to plug those things in. So 547, and N1 is 2103. Okay, and then our 368 and 1671. Okay, and so then we need to determine, are we just looking at a two-tailed test? They are not the same. Is the first one less than the other one or greater than? Okay. Now, if we kind of go back here and read here, it wants to know Nasonex experience. So Nasonex, where the group 1 is greater than the control group, okay, which is P2. Okay, so we want greater than for that. Okay, so we want to make sure here that we have greater than selected. And we're going to hit calculate. Okay, so we'll come to all those pieces in just a minute. All right, so we can see that they agreed with us. We get to the bottom of this paragraph, we see that P1 is greater than P2 as well. Okay. All right, so a few things. You're going to see that they're calculating. They have P hat here at 0.242, and we have that as well right down here at the bottom. So P hat. Z sub 0, they get 2.85, but we actually get that up here at 2.84. That's a rounding difference. That's okay. All right. Now, we want to compare that to our critical region. And so our alpha was 0.05. Well, if we go back and look at our charts, our Z table at 0.05, that's a 95% piece there. And so we'd get 1.645. All right. And so since our 284 or 285 is greater than 1.645, we would reject the null hypothesis. Okay. Now we could also do our p-value, and so we calculate that. So they go through again and calculate some of those pieces. Now we see here we have our p-value, and so we compare those. So that's 0.022 or 23, which is what is on the screen there for those. Now that is less than 0.05, so we know there that we're going to reject the null hypothesis. Okay. All right, now that we know that we can find those, we also want to know, can we find our confidence intervals? Okay, so let's look at those. All right, so we still have a lot of the same things here, dealing with those confidence intervals. So let's kind of get on to our pieces. So this is how you would do it by hand. But we're going to compare here. So we have these surveys, and we want to look at the confidence interval here for 90%. And so one group, we had 1,100, and we see two different values there for those. Sorry. We had 737 of the 1,100 and 784 of the 1024 that responded to the survey there. Okay? All right. So now we just need to break apart our pieces and make sure we're paying attention to those. All right, so since we're doing an interval, so this one was for the test. What about the interval? Okay, So for the interval, again, we are going to go back into stat. We're going to move over to tests. And then we're going to go down to 2 prop z interval. 2 dash prop z interval. Okay, so that's B on my calculator. All right, so we want to put in that information. So our first X1 and N1 was 784 and 1024. Okay, and then our X2, N2, 737 and 1100. And we wanted a 90%, so 0.9. We calculate there for those. Okay. All right, and so you can see a couple of things there. They calculated p hat. We have those as well for those. But our interval, just like you'll see here in a moment, once they get it, so their lower bound is 0.064. Well, our lower bound as well is 0.064. And then their upper bound is 0.128, and ours is as well. And so we're able to get those things. And so they actually did theirs in the calculator as well when using technology. All right, and so we have our interval there for those pieces. All right, now what about finding how many we need, the size of our sample for this to work? Okay, so we have this long formula for those. Now we have one formula for if we know the estimate, and then one formula if we don't. Now this is all just plug and chug. You have to know the formula, so make sure you're paying attention to it. Excuse me today. All right, so here wants to look at the size. We have 95%, 3 percentage points. And then part A, we know our percentages. All right, so we break those things down, our z of alpha over 2, because it was a 95%, is a 1.96, and we plug in accordingly. Okay, so making sure we keep up with brackets and parentheses for all those pieces. And so that means that we would need 1,863 for our survey on those pieces. Now, if we don't know any prior estimates, we use 0.5 for all of that stuff, plug that in, and so that tells us we need 2,135. All right, so those are the things we're going to need here in 11.1.